Okay, and here we're going with set 13, number 8. This is an interesting one. This is different, and I'll explain why a little later. Essentially, it's very much like an in excess reagent type question. So let's have a look at where we are, what the question is. We have a water tank which is 15,000 litres of bore water, has a pH of 5.5. In an effort to increase the pH, 10 grams of sodium hydroxide was added to the water in the tank. Determine the pH of the resulting solution. Assume that the volume does not change on adding the solid. And it wouldn't, 10 grams to 15,000 litres, the change would indeed be negligible. So, first thing that we need to do is we need to find out the hydrogen ion concentration here. Our strategy is to find the hydrogen ion, number of those, and then to find the number of hydroxide ions that we are adding here. We will then need to compare the two to see which one remains in excess after they've been added, and then calculate the pH on or any other details that we need on the residue left over. So first off, let's have a look at the hydrogen ion concentration. We know that pH equals negative log of the hydrogen ion concentration, okay, which equals to 10 to the minus 5.5. This is moles litre, but to know the number of moles that we have, moles per litre, N equals moles times volume, or if you like, N equals C times V, as we have seen before, okay, which is equal to, when you put it through, you will find that we have something like 4.7432 times 10 to the minus 2 moles of hydrogen ion. Not that much when you think about the huge volume of the thing that's there. Okay, let's turn our attention to the hydroxide, or the N hydroxide. Okay, so we're told that we have N equals mass on molar mass, which is equal to 10 on 39.998. Near enough, 39 on 40 equals 0.25. I won't tell if you won't tell about the 3 digits and then something. It's beyond our 3 points of significance any rate. Okay, so now we can quite clearly see that the hydroxide is the big guy in all of this, and that the hydrogen ion is the little guy on that. So we're really interested in the NOH remaining, which is going to be equal to this guy, 0.25, minus this guy, 4.743. Might as well chuck all the kitchen sink of the significant figures, we'll trim them back later, times 10 to the minus 2. If you put that in your calculator, you should come up with a number of 2.02 566 raised to 10 to the minus 1 mole OH. Now, that's very nice. That gives us a number of moles. Okay, to know our pH, because it's actually asking us pH, we need to derive that from concentration, which is moles per litre. So our concentration is going to be equal to N, number of moles, divided by litres, which is going to be 2.02566 times 10 to the minus 1, divided by 1/15,100,000 litres, which, if you do that particular sum, should give you a number of about, where's my concentration gone? My concentration on this particular one is 1.35044 times 10 to the minus 5 mole per litre. Okay, hydrogen ion concentration, which we need to calculate our pH, equals our Kw divided by our hydroxide ion concentration, which, if you put 10 to the minus 14 on that mess there, 1.353, (1.35044) times 10 to minus 5, you'll get a value of, oh dear, what was it? It looked like 7.4049 times 10 to the minus, sorry, no, I've got that wrong. No, I have got that right. 10 to the minus 10. And the negative log of that is equal to 9.13 if you work it out. And that is our pH, i.e. our pH equals that. Okay, quite a mess of calculations to go through. Let's just review. Where's my pointer gone? Let's review our strategy. We're told a pH and a volume. From that, we calculate the number of hydrogen ions present. Okay, the number of moles that are present divided by the volume to get that value. That gives us the number of hydrogen ions in total. We calculate the number of hydroxide that we added. We subtract the smaller from the bigger, and it gives us the excess reagent, which is, in this case, the hydroxide. So this is the excess amount of hydroxide that's remaining. We divide that by the volume, 15,000 litres. Okay, so the amount of hydroxide remaining divided by the volume gives us a concentration of hydroxide. We do the usual pH woo-woo of calculating from the hydrogen ion concentration from the Kw, and then we just put that into our pH formula, which is minus log of hydrogen ion concentration, and that gives us 9.13. And that's how to tackle that one. I hope it was of some help.